graphing equations by plotting points. All right, so what we're going to do, if we have it solved as y equals, we get to just choose values for x. And I like to do some negative and some positive. And then we're going to just calculate out the y values. So here we go. All right, so if I have -2, and I'm going to square that, and give myself a little room. Okay, so -2 quantity squared plus 3. We're just going to plug that into the equation. Let's see, that'd be 4 plus 3, so the y value there would be 7, and that is an ordered pair. So I can go ahead and plot that back 2 and then up 7. 1, 2, 3, 4, 5, 6, 7. So there's my first point. And you just keep doing that with all of the x values that you chose. And let's see, here we would get 1 plus 3, so that would be 4. And we just go through and plot that 1, 2, 3, 4. And then 0 squared plus 3, so just plugging that in place of x, we would get y for the value of 3. 1, 2, 3. And plugging in 1. Notice that that ends up being a pattern here. That's 4. And then that happens as well with 2. If we square that and then add 3, we'd get 7, which is what we got here. So there is a kind of a mirrored point right over here. And then if we put in 3 squared plus 3, we would get 9 plus 3, which is 12. And so that would be over here. All right, so that's kind of your classic graph for a y equals x squared kind of an equation for a quadratic. There's this U-shaped called a parabola. And notice that there's a mirror image going through that lowest point, that's the vertex. All right, let's do another one. All right, so on this one, I'm going to put in a few points, -5, -3, -1, 0, 1, and 3. Okay, so now I calculate my y. So I choose your x and calculate your y. Okay, so putting in a x value of -5, I would get y is equal to -5 plus 3, which would be the square root of -2. That's not a real number. And so that just is not in the graph. There's no point there when x is -5. Let's try the next one. If x is -3, we'd get -3 plus 3, which is the square root of 0, which is 0. So there's an ordered pair. -3, 1, 2, 3, and 0. And now let's try our next one. -1 plus 2, plus 3, that would be the square root of 2, and that's about 1.4. So that square root of 2, I'm going to graph that ordered pair, -1, and then it's about 1.4. And here, if we put in 0 plus 3, we would get the square root of 3, and that's approximately 1.7. So I'll plot that point, about 1.7. And then if we get 1 for x, we plug that in, we'd get the square root of 4, which is 2. So there's another ordered pair. And then we have the square root of 3 plus 3. And actually, I'm going to just change that. I'm going to put in a 6 so that that's a nice even number there. And because I get to choose whatever I want, so you can decide what you want. I'm going to just have that be 6, and then that would be square root of 9, which is 3. And there's my ordered pair. Okay, so I graphed this one already. This one wasn't in the graph. Let's go ahead and do this one. -1 and 1.4. So that's about there. And 0, 1.7, 1, 2. I'm right here. And at 6, so that'll be over here, I'm up at 3. All right, so my graph, need to make sure I show a line going there because the graph is actually all the infinite numbers. I could have put in a half, I could have put in 5 and 4 and everything for x. So I need to show that it's all the possible values of x. So make sure you have a line there. And then that's kind of your classic square root graph, kind of a nice gentle hill. Now this one, we've got the absolute value, but notice I have x equals y, the absolute value of y minus 4. So I'm going to choose some y values, and then I'll actually go through and calculate my x values. So here we go. The y values that I want for this one, I'm going to do 2, 3, 4, 5, 6, and 7. And now I get to go through and calculate my x. So for this first one, I'm going to do x equals the absolute value of y, which I'm going to plug in as 2 minus 4. And that would be the absolute value of negative 2, and absolute value is the distance from 0, so that has a value of 2. So there's my first ordered pair, 2, 2. Now, in the next one, if I put in a 3, I'd get absolute value of 3 minus 4, which is absolute value of negative 1, which simplifies to 1. So 1 and 3. And if I put in a 4, I'd get absolute value of 4 minus 4, which is just 0. So there's my next one. And then if I put in a 5, I've got 5 minus 4. Absolute value of that is 1. 1, 5. And the next one is absolute value of 6 minus 4, which would be 2. And you can see that this is just going to keep going up by one value. So absolute value of 7 minus 4 would be 3. And then to finish that off, we just want to connect our points with a line. And that's your classic absolute value, is kind of a V. If it's x equals absolute value, then the V opens along that x-axis, and if it's y equals absolute value of x, then it opens upwards. So there's your classic absolute value. On this next one, I have a squared term, so there's a quadratic, but the y is the variable that's squared. When you have an equation that's not set up with x equals or y equals, that's your first step, is isolate. In this case, we're going to isolate the x. So I'm going to add y squared to both sides. So I would get x plus 2 equals y squared. And then just keep going. We want to get x alone. X equals y squared minus 2. We could have solved for y. We could have gone like this. But then we would have needed to take the square root of both sides, taking both positive and negative. And then we would have had to graph two different lines. Okay, so that's not wrong, it's just harder. So instead of doing all of that work, I'm just going to solve for my x, and then I just have one equation that I graph. So there's my equation I'm going to work on. So choose some y's, calculate your x's. And the y values that I want to choose here is negative 2, negative 1, 0, 1, 2, and 3. Okay, so here we go. X is equal to y squared, so negative 2 squared, and then minus 2. So that would be 4 minus 2, which is a positive 2. The next one is x equals negative 1 squared minus 2. That would be 1 minus 2, which is negative 1. And then we would get 0 squared minus 2, which is just negative 2. And keep going here. We would get, with putting in a 1 for y, we'd get 1 squared minus 2, which is negative 1. And finally, x squared is equal to 2 squared minus 2. That's 4 minus 2. And then we have 3 squared, which would be 9 minus 2, which is 7. Okay, and then I can just go through and graph all these ordered pairs. Okay, so here we go. First one is at 2, so we go over 2, down 2. Next one is at negative 1, negative 1, negative 2, 0, negative 1, 0, 2, 2. and 7. 1, 2, 3, 4, 5, 6, 7, and 3. Okay, so we have that parabola, that U shape again, but when it's x equals y squared, it opens horizontally. So it's going to open horizontally, and if it had been y equals x squared, then that opens up. Okay, so there's your quadratics.